Okay, guys, we are going to talk about hypothesis, theory, and law today. Those are the three big terms. There'll be a couple other terms within this same slide deck that aren't listed here on the main thing, but I just want to kind of get you all familiar with the difference between these different terms in science. So let's go ahead and let's start this. So, what's the difference between all these different terms? The five terms that you guys need to kind of be familiar with throughout all of this is fact, hypothesis, law, theory, and belief. And I want to show you this picture when we first start. It's going to make more sense as we carry on and as we go throughout this slide deck. But I want to start here. I want to go ahead and give you this so you kind of know what is going to be talked about. So it kind of starts from the outside and it works its way in, kind of like the layers of an onion. You start from the outside and you work your way in to the core. So a fact. A fact is a basic statement established by experiment or observation. All facts are true under specific conditions. Some facts may be false when retested with better instruments. So, to pretty much break down what that is saying, it becomes fact after it's been either experimented on or it's been observed. And that fact is true under a specific condition. So, for example, it is raining outside. That is a fact when it's actually raining. When it's sunny outside, right, that's a different specific condition, so it's no longer raining. A dog is a mammal. That is a fact that has been observed, that's been experimented. The sky is blue. That's another one. It's under those specific conditions, right? When it's raining or when it's storming out, the sky is gray or the sky is black. Grass is green. That's another one under specific conditions. If it's healthy grass, if it's had rain, if it's had water, then it's green, right? But those are all factual statements under the specific conditions. Now, hypothesis, this is something that you should be more familiar with because we've talked about this a couple times now with your vocabulary and with the parts of an experiment. But a hypothesis is a tentative statement such as, if A happens, then B must happen, that can be tested by direct experiment or observation. A proven hypothesis can be expressed as a law or a theory. So here we go, moving through these layers like that was shown in that first picture. So a proven hypothesis can then be expressed as a law or a theory. A disproven hypothesis, however, can sometimes be retested and found correct as measurements improve. So as we talked early last week about how science is ever changing, this is an example of that. A hypothesis that was once tested or that was once disproven, as measurements improve, as new things are discovered, and as more technology is created, disproven hypothesis can be retested and found correct as those measurements improve. So, a hypothesis can have different definitions depending on the context it's being used. It can be called an educated guess, and that would be because it provides a suggested solution based on evidence to be a scientific hypothesis. So sometimes people would say, this is an educated guess, kind of like I'm taking my best guess based on the material that's been presented to me. A prediction, that's predicting the outcome of an experiment. And typically, when you're designing an experiment, your hypothesis in that way was a prediction, right? You always make the hypothesis before you perform the experiment, and you're predicting the outcome of that experiment. And another way that word can be used is as a tentative or proposed explanation. So hypotheses can be suggestions about why something is observed, but in order for that statement to be scientific, it must be able to be tested to see that it works. So if it is able to be correctly predicted, what will happen in that situation, such as if my hypothesis is correct, or we should see blank result when we perform blank test. So those would be examples of a tentative or proposed explanation. Because the difference between a prediction and this proposed explanation is, as a prediction, you're saying, I believe that flowers that are put in the sunlight will grow taller than those that were in the dark. Versus this, you would say, we should see the result of the flower growing taller in the sunlight when we perform the flower test, or however you would want to word that. But those are the two differences. A lot of these, they're very similar because it's the same idea, but they can be used differently depending on the context in which you're using it. So now we move on to a law, a logical relationship between two or more things that is based on a variety of facts and proven hypothesis. It is often a mathematical statement of how two or more quantities relate to each other. So sometimes within science, there are certain laws that have to do with mathematics. So for example, like pi is 3.14. That is a law. And here we go. A law is based on proven hypotheses. So what we had just talked about, when those have been tested and proven to be true, they can then potentially become a law. A law is a relationship that exists between variables in a group of data, and they describe the patterns we see in large amounts of data, but do not describe why the patterns exist. So laws describe a pattern, but not why that pattern is there. A theory, however, is an explanation for why certain laws and facts exist that can be tested to determine its accuracy. So before we said that a law describes the patterns you see, but not why the patterns exist. Well, the theory explains why the pattern exists. Theory is an explanation of natural phenomenon and why we observe something. They are not predictions, although we may use them as to make predictions. So as a prediction, that's kind of like that educated guess we were talking about. You may use a theory to support your prediction, but a theory itself is not a prediction. Theories are not likely to change because they have so much support and they're able to explain satisfactorily so many observations. So your prediction, right, that's just something that you're making. Whereas a theory, it's not been proven to be a law or a fact, but it has so much support that it's pretty close. In order for them to change, so it's not that they will never change, it's just that they aren't likely to. In order for them to change, there must be many observations or evidence that the theory cannot explain. So there needs to be some type of evidence there that is refuting what the theory is saying. So as I said, your prediction, that's a guess. That's your idea about something. A theory is not that. So law versus theory. People get these confused a lot. Down here at the bottom, I put theories explain why we observe what we do, and laws describe what happens. So I'm not going to play this right now in the slide deck. We're going to take a break here on Edpuzzle, and this is where you're going to watch this video. So finally, we have a belief. A belief is a statement that is not scientifically provable in the same way as facts, laws, hypotheses, or theories. Scientifically disproven beliefs can still be held to be true, just outside the realm of science. So you may have a belief. One thing that comes to mind when we talk about beliefs is something like a religious belief, right? We have all these different religions all around the world, even within your class. You have some classmates that believe differently than you do. Scientifically, they may not, or some of those beliefs may not be scientific, but that doesn't mean that they're not true outside the world of science. So, in summary, a hypothesis is a tentative explanation that can be tested by further investigation. A theory is a well supported explanation of observations. A scientific law is a statement that summarizes the relationship between variables. And an experiment is a controlled method of testing a hypothesis. So here we have this picture one last time. Now that we've talked through everything, you understand that testable explanations then turn into hypotheses. And once hypotheses are tested and they continue to be proven to be true, then they can be considered theories. Same is true over here, and hypotheses could actually be in both of these because hypotheses tested can also become laws if they have enough evidence. The difference is laws typically are mathematical. But over here on this one, this kind of looks like a deviled egg or a boiled egg. You have facts first, and as facts are supported and tested, then they can become laws.